Okay, so this is what we did last time. We talked about precipitation or double replacement reactions. And so let me just go through it very briefly just to make sure we're all on the same page. So first thing we want to do here to figure out what chemicals we make is we want to start off by figuring what ions make up these chemicals. Okay, so if we take a look at MgBr2, we just want to break this down into the positive, the cation, and the negative, the anion. So if you take a look at the solubility table, it's an easy way to break it down. So what's the positive ion that comes out of MgBr2? Okay, what's the positive one that comes out of this? Yeah, Mg positive 2. Okay, so you should automatically be able to see that it is Mg plus 2. Okay, and if you need help seeing that, you can check the solubility table. You see Mg positive 2 right here. Okay. Okay, let's go on to the negative one. What's the anion, the negative one that comes out of this? Yeah, we got Br minus right here. Okay. So Br minus. Okay, I know there's two of them, but it's okay. We can just write one of the Br minuses. If you want to write both, that's totally fine too. Okay. So those are the two ions that come out of there. Okay, let's move on to the next one. The next one, I'll do it a little bit more quickly. The positive one is Ag plus, and you can see that on your solubility table right here, Ag plus. And then the negative one is NO3 minus. That is nitrate. So NO3 minus. So those are the two anions, or the positive and the negative ions that come out. Okay. Any questions on how we broke those down? Okay. All right. So like we learned last time, it's double replacement. So you take the positive of one of them and the negative of the other one, and then you put them together. So we got positive 2 right here, Mg. So we're going to write Mg, and it's going to react with the negative of the other one. So NO3. So we're going to put it next to NO3. So if these two react, do we have more positive energy or more negative energy? Yeah, we got more positive energy. So we need more negative energy. So we're going to need 2 of the nitrate. So we can do that by putting a 2 in parentheses. Okay. So that's the first chemical that we're going to make. All right. All right, for the next one, we got Ag. So we're going to put Ag, and we got Br. And if you guys notice, it's positive 1 and negative 1, so it's already balanced out. So we can just leave it exactly the way it is. Okay? All right, so we've been doing this stuff for a while, the ionic compounds, but does anyone have any questions on this part? You guys chilling? Okay. All right, now the next thing that we have to do is we want to make sure it is balanced. So we got to have the same amount of everything on both sides. So let me just expand this out real quick. You guys don't need to write this out. Actually, no, I'm gonna leave that alone. Sorry. Okay, so let's count. So we got 1 Mg on this side, the left side. How many Mgs do we have on the right side? Yeah, just 1. We got 1 Mg right here. All right, so we got 1 Mg on both sides. Let's go to the Br. So we have 2 Brs on the left side. How many Brs do we have on the right side? Just 1, right? So that means we need another one on the right side. So what we're gonna do is we're just gonna put a 2 in front of the chemical that has Br on the right side, and that way we have 2 Brs. Okay, let's look on the left side again. If we go to Ag, how many Ags are on the left side? Just 1. How many are on the right side? 2. So same thing as before, we're going to put a 2 in front of AgNO3, and that actually works out really well because if you notice, there are 2 NO3s on the right side, and now we have 2 NO3s on the left side as well. So for balancing, you just need to put a 2 in front of this and a 2 in front of that. Okay. All right, almost done. We need to check the solubility. So I'm going to give you guys I'll give you guys a minute. I want you guys to figure out if on the right side, if the chemicals dissolve in water or not. So you're going to put A, Q, or S, whether it dissolves in water or not. I'll give you the answers to the ones on the left. They're both aqueous. They both dissolve in water. But I'll give you guys a minute to figure out if these two chemicals on the right side, if they dissolve in water or not. Okay. So use your solubility table to figure that out, and we'll go over that in a minute. Okay, so Mg and NO3, they line up right here, SOL. So that dissolves in water. So we're going to write AQ in the parentheses after MgNO3 too. Okay. All right, the next one is AgBr. So what we're going to do is we're going to go to the solubility table, look for Ag, line it up with Br, and it looks like this one does not dissolve in water. So if it doesn't dissolve in water, what do we write in the parentheses after AgBr? S. Good. So this one is going to be a solid. So when you mix these two compounds together, even though they both dissolve in water, they'll probably look clear to you. You're going to produce this precipitate, this chunk that comes out. Okay. All right, we'll finish up with the picture. So for the left side, what you're going to do is you're just going to put the ions that you have. Since they both dissolve in water, you're just going to write Mg2 plus, Ag plus. So basically, you're just putting the ions that make up the compounds right here. Okay. All right, but then on the right side, when you combine those two compounds together, one of them is going to stay separated. So Mg2 plus and NO3 minus, they're going to stay as their ions because they're dissolved in water. But this compound right here, AgBr, since it's a solid, it's just going to hang out on the bottom as a solid. So something like that for your picture should work fine. Okay. So hopefully this is pretty familiar now, not too bad. As long as you get this part correct, the picture should come pretty naturally. Okay. All right, one last thing, and this is the one new thing we're adding on today. It says to write the full name of the precipitate. So we're just gonna practice writing names again. We did this before already. We're gonna write the name of AgBr. Okay, so we got AgBr. All right, so to write the name of AgBr, what we're gonna do is we're gonna start by using the rules on the naming chart. Do you guys still need the picture? Still copying it down? Okay, I'm going to get rid of it then. So we're going to go to the naming rules. So when we go to the naming rules, remember, we always start with the cation first and the anion second. So the chemical we're working with, we're trying to find the name for, is AgBr. Okay? Now, we know that we have to write Ag first. So if we go to the periodic table, what chemical or what element is Ag? Silver. Good. So this is going to be silver. So AgBr, we're going to start by writing the name silver. Okay, so we're going to write silver. Okay, now we have to double check if silver follows this rule right here or this rule right here. Okay, so if we take a look at the periodic table, silver is in the middle, right? So if silver is in the middle, does it have an MCI? No, right? It doesn't have the number on the top. So if silver does not have an MCI, since it's in this middle section right here, what we have to do is we have to write the charge in Roman numerals, okay? So for AgBr, what was the positive energy that it had? Anyone remember? Yeah, it was 1. It was positive 1. So since it's positive 1, we're going to do parentheses 1, and that's going to be for the cation, okay? It's going to be silver 1. And again, it's because, if you guys remember from the solubility table, silver was positive 1. This is the silver that we used. So that's why we write silver 1. Okay, let's go to the second part. The second part is the anion, so we're going to write the negative 1. So the negative 1 is Br. So if we take a look at the periodic table, what element is Br? Yeah, bromine, right? So it's bromine, but since we get the anion from the periodic table, we have to change the ending with IDE. So instead of bromine, it's going to be bromide. Okay, so AgBr, the full name is silver 1 bromide. Okay, and that's pretty much it. Okay, so we're kind of putting everything that we learned, basically since the semester started, all together, and then today you'll be practicing this, and then on Thursday we'll be doing the pre-lab, and then on next Tuesday you'll be doing the actual lab where you mix these chemicals, figure out if you make a precipitate or not. Okay, that's pretty much it. All right, so I'll give you guys the rest of the class period to work on your assignment. Your assignment today is called Precipitation Reactions Practice. It is 7 questions, so could take a little bit of time, so just make sure you're using your time wisely. If you have any questions, you want to check your answers with me, please let me know, okay? But I'll give you the rest of the class period to work.